So if we're looking at metals, one of the things to remember about them is that there's a high electrical conductivity for them. That means electricity can flow through it easily. Copper, for example. Gold is actually a good conductor. There's a high thermal conductivity. That means that thermal energy can go through it. If you think of your pots and pans, a lot of them have copper bottoms because copper allows for thermal conductivity. And we're not going to worry about shininess. Now, if we take two metals and form them together, we get what's called an alloy. Gold and palladium form white gold, for example, and that's an alloy. It's a combination of them. Now, the properties are pretty important. So, for example, if you look at the Sacagawea gold dollar, that became popular a couple of years ago. But you also have to remember, we got to think about what kind of ramifications are there when you introduce a brand new coin. So look at vending machines, for example. If you had a Susan B. Anthony could be used in electrical machines, like vending machines. Now, I would never do that because a Susan B. Anthony is worth more than just $1 that you would get out of it. But it has a certain set of electrical characteristics because when you put a coin through the vending machine, it sends a current through it and it reads the electrical characteristics of it. So that's how it knows whether it's a penny, nickel, dime, quarter, half dollar, or silver dollar, something like that. So when they designed the Sacagawea, they were left with an option. Do we either replace every single vending machine to now recognize these gold dollar coins, or do we make the Sacagawea gold coin to mimic the electrical characteristics of the Susan B. Anthony's, which probably guess it would be a lot cheaper and a lot easier to have it mimic the properties there. So nonmetals are on the right of the periodic table. They're dull, they're transparent, they're the ones talking, by themselves and kind of dull. So low densities, low melting points, chemical properties, they tend to gain electrons easily. Now metalloids kind of fall into the middle category. So boron, silicon, germanium. If we look at this particular periodic table and we scroll down, a lot of times when you look at periodic tables, especially the ones I would always see in textbooks, I would get this heavy black line. Boron, aluminum, silicon, germanium, arsenic, antimony. These are your metalloids. These are kind of those hybrids. These are materials that contain both characteristics of metals and metalloids. So silicon, for example, computer chips, they're useful for semiconductors. So Silicon Valley. So this is where the metalloids fall into play because it kind of has characteristics of both. It's not a good conductor, but it's not a bad conductor. So it plays in really nicely for semiconductors. So what I want to do is the following. I'm going to read an article for you. This was actually published in the Denver Post. This was, you can think about it as sign my petition, needs your voice, whatever. I'm going to read off a particular compound, and I want to know how many of you would be in favor of banning this particular compound. Now, everything that I'm going to tell you is completely true. There is nothing that's being falsified, and this was published, and this was a petition to have people sign it. So I actually need to give you a little bit more information before we get into the activity because we've got to look at compounds. And how do we name compounds? So NaCl is a combination of sodium and chloride. It's called table salt. Now what's interesting though is when we have compounds, the property are different than what they are initially. So if we look at, for example, table salt, I can eat salt. We eat it all the time. We use it on our food. Pure sodium, for example, if you remember the Brainiacs video, when sodium comes into contact with water, if it's pure sodium, it's going to explode. Don't want to put that in my mouth. Chlorine, kind of what you put in pools. I don't want to put chlorine in my body either. But yet you combine the two and you get table salt. And that's perfectly edible. So compounds have different characteristics than what the individual elements are. So when we're naming these compounds, we typically do the following. We have the element on the left followed by the element on the right. So on the periodic table. So hydrogen is on the left, chlorine is on the right. So we have hydrogen chloride, HCl. So we have the "ide" there. If I have two more compounds with different numbers of the same element, we add prefixes. So for example, CO is carbon monoxide, CO2 is carbon dioxide. And sometimes we refer to things by their water names, water, ammonia. So a mixture is a collection of two or more pure substances, but when they're put together, the individual substances retain their original characteristics. So we can make it as a homogeneous or heterogeneous. So these substances are evenly distributed throughout. Tap water, rose gold. A heterogeneous mixture is marble. You can see the differences in it. A salad is a heterogeneous mixture. A lot of plastics. So now that we know a little bit about compounds, let's actually see if this article that was published in the Denver Post is something you would want to ban. So ban dihydrogen monoxide. Dihydrogen monoxide is colorless, odorless, tasteless, and kills uncounted thousands of people every year. Most of these deaths are caused by accidental inhalation of DHMO, but the dangers of dihydrogen monoxide do not end there. Prolonged exposure to its solid form causes severe tissue damage. Symptoms of DHMO ingestion can include excessive sweating and urination, and possibly a bloated feeling, nausea, vomiting, and body electrolyte imbalance. For those who have become dependent, DHMO withdrawal means certain death, and it has been dubbed the invisible killer. Dihydrogen monoxide is also known as hydroxyl acid and is the major component of acid rain. It contributes to the greenhouse effect and may cause severe burns, contributes to the erosion of our natural landscape, accelerates corrosion and rusting of many metals, and may cause electrical failures and decrease effectiveness of automobile brakes. Has been found in excised tumors of terminal cancer patients. Quantities of dihydrogen monoxide have been found in almost every stream, lake, and reservoir in America today, but the pollution is global and the contaminant has even been found in Antarctic ice. DHMO has caused millions of dollars of property damage in the Midwest and recently California and Louisiana, where hundreds lost their homes, properties, and some even their lives. Despite the danger, dihydrogen monoxide is often used as an industrial solvent and coolant. It's used in nuclear power plants, it's in the production of styrofoam, as a fire retardant, in many forms of cruel animal research, and in the distribution of pesticides, even after washing produce remains contaminated by this chemical. It's also an additive in certain junk foods and other food products. Companies will dump waste DHMO into rivers and the ocean, and nothing can be done to stop them because this practice is still legal. The impact on wildlife is extreme, and we cannot afford to ignore it any longer. The American government has refused to ban the production, distribution, and use of this damaging chemical due to its quote-unquote importance to the economic health of this nation. In fact, the Navy and other military organizations are conducting experiments with DHMO and designing multi-billion-dollar devices to control and utilize it during warfare situations. Hundreds of military research facilities receive tons of it through a highly sophisticated underground distribution network. Many store large quantities for later use. Act now to prevent further contamination. What you don't know can hurt you and others throughout the world. So my question for you is, would you ban this? Think about it based upon the information I provided. Nothing is wrong there. All of that information is entirely 100% accurate, and this was published, and this was a petition for people to sign this chemical. So put your answers in the answer sheet right now after you think about it. Okay, so now that you've thought about it, whether you'd sign a petition or not, and actually wrote in the paper why you would or would not sign a petition, I want you to think about the name dihydrogen monoxide. Dihydrogen, di, what does di mean? Di means two. Hydrogen, two hydrogens. Mono means one oxide, one oxygen. One oxygen, two hydrogens, H2O. It's a petition to ban water. Now, if you look back at some of these different things within here, it's a fire retardant. Water is a fire retardant. Water is used in pesticides. Even after you wash your produce, there's still going to be water on it. Water has been found in Antarctic ice. Water can cause severe burns. Water contributes to the greenhouse effect. It is the major component of acid rain because it is the water. Now, I like ending with this when we're talking about content because, one of the major purposes of this course is to get you to develop things, scientific literacy, and to think about things critically. There was a comedy show for guys several years ago, Jimmy Kimmel, Adam Carolla. And so they would go out and they were at a pier and they were getting women to sign a petition to end women's suffrage. And they were getting a lot of people to sign this. And so what had happened is we talk about how this is a terrible thing and we need to end the suffering now. Well, in actuality, what women's suffrage is the right to vote. So by not knowing what it is you're actually signing and not knowing the full details of it, that lack of knowledge can be more dangerous than knowing what it is you're doing. Now, like I said, this was actually published in the Denver Post, and everything here is entirely correct. So if you go back and re-listen to this video and thinking about it in terms of water, It's all correct. This was actually a middle school science fair project from a student out in Colorado, and he tried to get students or he tried to get people and adults to sign this petition. So his science experiment was thinking about scientific literacy and within general population, and I believe he actually got a politician who helped campaign a little bit to sign and to ban this particular chemical. So think about this in terms of the course, looking at, what is it you don't know and what is it that you're doing and how that can affect you and how can you look at this in terms of a scientific standpoint. Hopefully some of you were thinking that, oh, well, I feel like I'm only getting part of the puzzle. And so if I don't have the whole puzzle, then I can't understand it. And so hopefully that's exactly what happened. So we're going to do a couple other experiments offline, and I look forward to chatting more with you sometime soon.